Assalamu alaikum ji. Am I audible?
Yes, G. Marosh,
Okay.
you continue.
Assalamu alaikum and good morning, everyone. My name is Mehoosh Fatima and I'm Assistant Director Mobility and Vehicles at National Energy Efficiency and Conservation Authority. On behalf of NEECA, I warmly welcome all our distinguished speakers and participants to this important webinar on EV conversions, legal, technical, and financial aspects. As we all know that Pakistan's transport sector plays a vital role in our economy and social life, but it is also one of the largest consumers of fossil fuels and a major contributor to greenhouse gas emissions. Nearly one third of our total energy consumption comes from transport, and the sector is overwhelmingly dependent on imported petroleum products. And we all know that the government of Pakistan has already introduced the National Electric Vehicle Policy to encourage adoption of electric two-wheelers, three-wheelers, and four-wheelers. But we know that the transition to new EVs requires significant upfront costs, which slows adoption, especially for low and middle income vehicle owners. So, to broaden the discussion, we have invited international experts working on EV conversions globally, as well as national experts leading projects in Pakistan. Through today's session, we will explore the legal, technical, and financial aspects of retrofitting, converting traditional combustion engine cars to electric, and we'll hear from both international and local experts on how Pakistan can make this transition successful. With that, let's move to our first distinguished speaker, Mr. Laurent Fruger. His company, Fuel to Electric, has been actively working on EV conversions of classic cars in the United States. He has also been leading global initiatives on retrofitting and conversions. Today, Mr. Laurent will share his experiences and insights on international best practices and give us a regional perspective from America with insights on how these initiatives can guide Pakistan's own EV transition. Mr. Laurent, over to you. Thank you.
Thank you very much for the introduction. I'm going to take 1 second to share my screen with you. And you should be able to see me and at the same time the presentation, but maybe I'll remove the video so it's more fluid. Thank you very much for the introduction. My name is Laurent Frugier. I am the CEO and co-founder of Fuel to Electric. But first, I would like to thank the Ministry of Energy and NEECA and also Merosh Fatima, who organized the event. I'm very honored to start this webinar and hope I'll be able to present some of the major aspects of EV conversion and all the forces in action that are needed to create the development of EV conversion. First, I will introduce Fuel to Electric and highlight some of the EV conversion projects around the world just to set the stage. So Fuel to Electric comes from the idea that the car of the future is already built. We have so many cars on the road everywhere. Most of the cars on the road today are built to last more than their engine. So replacing the existing engine with an electric motor is probably the best option for our environment. Now, we realize that if we want EV conversion to go mainstream, we'll need more than a team we could create ourselves. So we created this giant network of EV conversion professionals, and it's now the largest network of EV conversion professionals in the world. We have people mostly in USA, Canada, North America. We also have some partners in UK and more partners in France. We call them friends because we are not necessarily involved in a financial relationship or business relationship, but still we have people in Europe, Africa, Australia, and Middle East. It was said it has been mentioned in the introduction, the impact of EV conversion is very important for probably the best reason. We see that it's not always the driver for EV conversion, but it's very important to make sure that everybody understand the depth of GHG reduction just by comparing how much it costs to build a car. When I say cost, I mean the footprint, the GHG footprint of building a gas vehicle compared to building a brand new EV, compared to converting one existing car to electric. The ratio between gas vehicle and EV is 3. It costs 3 times less GHG than for an EV than for a gas vehicle. But the difference for EV conversion is even bigger because you can divide that number by 10, and that makes a huge difference. Gas emission is not only the difference, and actually I talked about the driver, what drives people to EV conversion. It's obviously environmental impact, but it's not the number one. The number one driver is the cost. So I'm gonna show you some of the examples we've seen around the world with some of our partners. So here we have an example of a bus, transit bus, and one specific example is the double-decker in London. The difference in price is huge. It costs 220,000 pounds to convert an existing bus compared to 550,000 pounds to buy a new one. So there is a big incentive here for anyone who's trying to save some money, but still wanting to electrify his fleet. Just have another example. It's in the city of Paris. It has recently replaced, the city of Paris placed an order with Heuliez and Bolloré and Alstom to purchase 800 electric buses for 400 million euros. That's €500,000 per unit. That's the cost of the replacement. And it's huge. When you see that, you can split the cost by 2. Now there is the cost of purchasing a unit, and there is the cost of operating a unit. And now it's just like any EV. We know there are big economy of scale, and the total cost of ownership is super interesting for electric vehicle. It's less maintenance, it's less energy cost, it's less operating costs, and also if you have a lot of traffic, if your vehicle stops a lot, then you're going to save also in idling. So this company is Zero Nox is based in the US. It's one of our partners as well. They've developed this project for refuse trucks in Ghana, and they made a huge partnership. They are converting now 1,000 vehicles, and in terms of saving, it's huge. In the next few years, they're going to make big savings. Now, something maybe an experience that is closer to us here in Arkansas, back to public transportation with a 16-passenger shuttle bus in the US. In this case, the cost of the uplift for such vehicle is so high that replacing its drivetrain with electric costs almost half of the price of a brand new EV. So it's 250 versus $400,000. So it's very interesting to see it in action. That's me taking this shooting this video. The driver love it, the passengers love it. They don't see any difference. It's only just smoother. And for all the stakeholders involved in the financing of this project, it's half of the cost. So everybody's happy. Now in another continent, 2 and 3 wheelers. That's a company. Actually, it's 2 companies. They have combined their forces, and they came up with a very interesting kit because there's no battery in the kit. Generate includes and sells the kit and perform the conversion. And the partners with Blue EV, and Blue EV provides a system of battery swap. So you buy a kit without the battery, which is very interesting financially wise, because you don't have to pay for the battery pack up front, and you lease the battery to another partner. You can lease the battery instead of buying it up front. That's one of the few innovations that we are following at the moment, and hope to create bridges between solutions and needs. So that's really what we do at Fuel to Electric. We raise awareness all around the world. We partner with companies. We combine efforts, and you'll rapidly understand why we need to combine efforts. I've talked about example. Now I want to talk about the challenges of EV conversion. There are 5 challenges, and it's enough. It's a huge work to achieve and to make sure that those challenges are overcome. We're going to see them one by one during this presentation. And at the same time, if you have questions, please raise your hands, or I'll try to keep up with the questions maybe after, if we still have time. The first challenge is the high upfront cost. And it's not, I said it costs half of the price of a brand new EV, but the development cost of a kit is expensive. So there is an economy of scales, but the first unit and the first vehicle that you're going to convert is very important. Not all use cases are good use cases for EV conversion. Now, I take you back to the shuttle that I showed you earlier, and that's displayed on the picture. This specific bus has some equipment. It has some uplifts, and everything you see here on the picture, the special cabin, the 12 passenger seats, the lift for the chair, everything has a cost. So if you have to replace this vehicle, first, you have to ask you, is there an electric version of this vehicle? If yes, go and get a price for it. There may be some cases where the price of a brand new EV is lower than the effort of converting this same vehicle. Has the vehicle been modified or uplifted? In this case, there is so much equipment in the bus that is attached to the bus that it would cost way more to buy a brand new EV and uplift it to the same level. So when you are comparing the price of EV conversion, you must compare it to the price of the final vehicle that you have. Obviously, any vehicle that has an engine problem is a good candidate. And if there is rust, then forget about it. It's very hard to add up the cost of restoration to EV conversion. EV conversion is or can be very expensive sometimes. So you need to find the right pricing for the right vehicle. Now, you have a vehicle, you ask the same questions and you feel like you have a good candidate, but who's going to perform the conversion? That's the second challenge. That's the lack of expertise and building skills where it matters is really important. We're working on different training programs in different countries. We have partners that have deployed their curriculum in Asia, Africa, Australia, US, almost everywhere. There is a big, huge potential, but this potential needs training. You need to be trained in many different areas. There's safety and protective equipment, or anything that you need in the facility, or all the tools. Then you need the battery and the high voltage system. There are some, just like the one I'm showing on the picture here, there are some training materials that will help for this, just like this bench specifically. And then there are also real world applications. So basically hands-on training programs. You have all the components displayed on the floor and you just have to put them on a car. And after a week or 10 days, you're able to drive this car. So these kind of programs are super important to develop the skills that will be required to, one, convert, two, support any conversion, and three, maintain all the vehicles on the road. Certification also are available. Not that much though. It's surprising, but there is no specific certification for EV conversion. There is one that we use. It's the Automotive Service Excellence. It's an American certification, and two levels are available for certification, different certification, and they are available online. So after the training, you can pass certification and get a diploma that will give you more visibility, or basically just gets you somewhere so you can apply for a job. And if you have a company, you can request for this certification. So back to next stage. You have now the vehicle. We talked about the training, and you are allowed, somehow you have a vehicle that drives, but are you sure you can drive it on the road? Is it roadworthy? Is it something that you can insure? Is it something that you can get passengers? That's the next point. Is it okay in Pakistan or in any country to put the vehicle you've converted on the road with passengers and or just people in the street? That's the regulatory gray area. And for this, there are standards. Are there standards though? For personal and private vehicles, there are no standards. No standards in the USA, no standards in the UK, and no standards in Europe. There are a few people working on it. Okay, one of them is the United Nations Economic Commission for Europe, and they are trying to work on something to deliver on harmonized requirements by 2027. So it's not that easy to create those standards, although for public transportation, because you have passengers and insurance is involved, there are two standards for public transportation in the UK that are very, very useful. They are available so you can get access to them. There are zebras and zebra. I really recommend anyone who's interested in reinforcing standards in your country to look at these standards. It's not about creating a new wheel. It's about using something and transpose these standards, existing standards, in a different context. That context would be Pakistan in your case. And also there are standards. There are two good questions, actually. I almost forgot. But the real question is, are there any standards in your country for importing brand new EVs? So if electric vehicles are coming from, I don't know, let's say China or India or whatever country, Japan, USA, what are the standards that your country is reinforcing to make sure that the streets are safe and the vehicles on the road are safe? Now, this is one question. The second question is, do you have rules already about swapping gas engines? If you swap one gas engine with another one, are there some standards? These are real questions, because if you want to reinforce standards for something new, you have to rely on something. And if there is nothing, then it's way harder. And in this case, you can, I call it the copy-paste of standards, copy-paste standards from other countries. So yeah, so that's about standards and all the work that has to be done. So let's pretend now that you have a vehicle, you've converted it because you've trained people that could do it, maintain it, and it's on the road, and you have the right to drive it on the road. Now comes the last challenge: is what about charging? What do we do? And that's the problem the electric vehicle industry in general has. We know that there is this range anxiety that you have to balance with efficiency. The more range you want, the heavier your vehicle will be, because the more battery you're going to put in, and the more expensive it's going to be. But also, the heavier it will be, the less efficient it will be. So the less miles per kilowatt hour you'll get. Now, there are plenty of new solutions, like battery energy storage solutions, BESS, and I think someone's gonna talk about it just after me, and also battery swapping, just like the company, the two companies I was talking about earlier. So this is to beat the range anxiety, and usually the EV, the brand new EV, will lead the pack, because they have the same problem. Most of the problems we have for EV conversion are not new problem. Swapping engine, it's already done. Importing electric vehicles and standards, it's already done. Charging, the problem exists already. Now, the last challenge is awareness. Of course, now you have a technical solution. You have the infrastructure, you have the training, the technicians, and everybody. But what you miss is the client. There is a huge effort to put in communication, because we are not just converting vehicles, we are converting people. We need to convince people, and not only convince, they need to understand that EV conversion is available, it's reliable, it's less expensive than a brand new vehicle, it's good for the planet. And EV conversion, I put it here, should be promoted, glorified, and subsidized. There is no other way EV conversion can exist besides being subsidized with programs from different organizations. And yeah, we have to work with the government to find ways to help this industry grow. And we also need more ambassadors like Ayman Shafiq. You probably know her from EV Square. She's based in Islamabad. She's done a huge work, and I would like to seize the opportunity to thank her for that, for all the work that she's been doing so far. As a conclusion, I'm running out of time. Powering a cleaner tomorrow together. It's not one company that's going to do all the work. There are many stakeholders involved, from the government to the infrastructure for electricity companies, to shops, local shops or bigger shops, to components, vendors. We need to create this, there is a momentum, and we need everybody to hop on the train of EV conversion. And again, if you want to do it alone, you're not gonna go far. So we need to work as a group and join our forces. Again, I would like to thank everybody for the opportunity. And if you have some questions for me, I'll be happy to answer them. Otherwise, I'm looking forward to listening to all the speakers. Thank you very much.
Thank you so much for your valuable insights, Mr. Frugal.
Thank you.
Mr. Frugal, I have a question. I saw on your website that Fuel to Electric offers a Nissan Leaf EV conversion kit along with a third-party VCU, that is Thunderstruck. Could you share your experience on how successful these Leaf motor conversion kits have been?
So the Leaf motor is one of the less expensive. It's also available massively. Now it's repurposed motors, and depends on the application. Really, we need to talk. A conversation about EV conversion can only start with a use case. Are we talking about a last mile delivery? Are we talking about public transportation? Are we talking about private cars? Are we talking about two-wheelers, three-wheelers? They all come with different challenges, technical challenges, the weight, the range, the auxiliary systems, the safety. So the voltage, in this case, the Nissan Leaf is a high voltage motor. So it's a cheap motor, but it has to come with a large battery pack to match the voltage, the minimum voltage that is required to run it. So there is the battery pack will cost way more than any other components that are necessary for the Nissan Leaf, which makes the whole kit more as expensive as any other kit.
Okay. Thank you, sir. We have with us Mr. Abdul Hadi, a highly experienced EV expert who has been guiding multiple initiatives on clean mobility in Pakistan. Sir, if you have any questions or points, please feel free to discuss with Mr. Frugal.
Thank you very much, Mr. Frugal, for such a kind, insightful conversion process. I have a very pertinent question: that what kind of challenges have you faced during your conversion regarding the L3 DC fast charging?
What are the challenges of DC fast charging?
Yes, just you were talking about the Nissan Leaf and it is a 365 volts battery pack. So, is there any L3 charging support available after the conversion is being done?
Let me rephrase. Your question is about upgrading a Nissan Leaf setup so it accepts fast charging.
I'll rephrase my question. Suppose we do a conversion. I mean to ask, does this conversion provide L3 DC fast charging support?
Well, so in this case, for the Nissan Leaf, what we do is usually we do not reuse the battery pack, the Nissan Leaf battery pack. We would use, if you want to use repurposed batteries, that would be Tesla batteries. There have been some, so it's been done reusing a Nissan Leaf battery, but it's not satisfying. Reusing Tesla battery is way more easier. It's also it's super available in the American market. So upgrading an existing NEEF battery pack for conversion is not something that we recommend. Using it is not something that we recommend. Upgrading it so it accepts fast charging, to my knowledge, it's never been done.
So the retrofitted cars would not be a good option if we want to use the commercial charging as option.
What would be the sorry, there's an echo in my headset. What would be a good option? This is what you are asking?
Yes, since as per your discussion, I think a converted car wouldn't be gets a charge from a DC fast charger or commercial charger. Is that the case?
Sir,
You can do.
Mr. Hadi is asking that the EV converted cars, is it possible to charge the EV converted cars through the DC fast chargers, or is it only possible through the AC chargers? Level 1 or level
No, I'm gonna be very everything is possible. This is my answer. Everything is possible, and almost everything has been done. Now it's again, in your case, we'll have to focus on your use case and what would be the usage, because the cost of implementing such solution can be prohibitive.
Okay. Thank you so much, sir, for sharing those valuable insights. Next, I would like to invite Mr. Ali Moin Malik, CEO of EasyBike, one of the pioneering companies driving the adoption of electric two-wheelers in Pakistan. EasyBike is not only promoting electric bike adoption, but also working on bike conversions. He will share his perspective on industry readiness and the future of conversions in Pakistan. Mr. Ali, the floor is yours. Thank you. Please carry on.
Yeah, thank you very much, Merosh. Thanks for having me. So just electric mobility solutions companies in Pakistan. So our focus is threefold. Number one, building electric bikes for the Pakistani consumer at their price point, for their payloads, and the Pakistani road infrastructure. Secondly, we obviously build batteries because we offer batteries as a service. Mr. Frugir mentioned battery swapping. We're the leading battery swapping company in Pakistan as well. So we build locally, build and operate the battery swapping infrastructure. I'm not going to go into too many details on the infra, but before I start, I think what I want to do is, like, if we really want to change the course of mobility in Pakistan, I think we're going to have to shift our conversations from cars to two and three wheelers, and I'll tell you why. There's less than 4 million cars in Pakistan. So for every 1,000 people, there's about 18 people who own cars. And that number is probably an overstatement because of people like me who own multiple cars. Even if it isn't 18 out of 1,000 people, owning cars is a very small number. It's one of the lowest car ownership rates in the world. Whereas if we look at our 2 and 3-wheeler market, we have close to 30 million motorcycles and rickshaws. So if we want to fundamentally change the way Pakistanis commute, we're going to have to start talking about the vehicles used by the many, not by the few. So I think that's something that I want to highlight on day one, which is why also we focus on the two-wheeler market. So my expertise is particularly on motorcycles. I can't really comment on rickshaws because that's something I haven't worked on. So we've done conversions. We're probably the only company that's done any kind of motorcycle conversion at any kind of scale. We just have a few hundred on the road, and there's certain things we've learned from that process that I would like to share. Essentially, I'm going to keep this very short. I don't want to take your guys too much time, but there's about 5 items that I want to talk about, items that we've thought that we've learned about. So, firstly, what is the benefit of converting a petrol engine motorcycle to electric? And the obvious answer is cost. You'd save costs. So how much would you save? In our experience, no more than 15%. So you'd save about 15% if you take an existing motorcycle and convert it to electric, as opposed to someone buying a brand new electric motorcycle. However, Pakistan's policymakers, in their infinite wisdom, decided to enact what I call an inverse tariff on local manufacturing. So let me just explain what that means. When I buy an electric bike, if I import it from China, I pay 1% sales tax on it and then I sell it for 1%. However, if I make something in Pakistan and then sell it in Pakistan, I have to pay an 18% sales tax. So effectively, if I convert an electric bike, my customer actually has to pay 18% sales tax on it. But if I give them a brand new one, they pay 1%. So that's effectively a 17% inverse tariff. This is the only country on the planet that does that. However, because of that, the 15% that you're going to save by converting the bike, you're going to end up paying more on sales tax. So there is no economic benefit of converting an electric bike, a petrol engine bike to electric with the given policy. So I want to state that very, very clearly off the top. The second issue with which we face with converting bikes is scalability. Now, if you want to run an effective business, you want to make sure that the business, whatever you're doing, is scalable. Unfortunately, conversion in Pakistan is not scalable. That's what we've learned, and I'll tell you why. The leading petrol engine motorcycle manufacturer in the country at its peak was offloading more than 6,000 bikes a day. However, when you talk about conversion, number one, let's break it down. Number one, you've got to take apart the bike, the original bike. Then, as Lauren mentioned earlier as well, there's rusting, there's damage because these bikes are not, because of the road infrastructure and the way they're used, they're heavily damaged. So then you have to repair the existing bike, and then finally you convert it. So a process that should take no longer than 30 minutes with a new bike will end up taking sometimes even 6 or 7 hours. So we after a few hundred, we kind of realized that there is no way we can scale this. We'll need such a large workforce just to do the conversion process. It makes no economic sense because the more people you put on there, the higher the cost of, obviously manufacturing goes as well. So scalability is a serious concern, particularly when it comes to motorcycles. And then finally, let's say we crack the scalability issue, and let's say that there was no inverse tariff and there's a definite cost saving. The final piece of the puzzle, or the second last piece of the puzzle, is whether it can be financed. Now, the challenge here is that no one in Pakistan, no bank or microfinance institution will finance an asset that is pre-owned by someone. So if you want to go and get a new petrol engine motorcycle finance, they'll do it. What they'll do is the asset will be registered in whoever is financing it in their name, and then they'll hand it over to the end user. And then once they've paid for it, they'll transfer it over to the end user. However, a used motorcycle is already in the end user's name. So we've tried this, we failed. Not a single taker. There was no financial institute in Pakistan that is willing to finance an asset that's already owned by the end user because there's no collateral. So without collateral, they're not going to dole out any money. So financing obviously fails. And finally, what about standards? At this point, this space is completely unregulated. But let's say I go and convert 10,000 bikes and I put them on the road, and tomorrow the government of Pakistan decides that it's gonna start regulating that. There is no regulation at this point. So what happens if they decide that these are not roadworthy for whatever reasons, or they need to go through the PSQC again, which is the Pakistan Quality Standards Association. They need to be let's say in a year from now or 6 months from now, the government decides that someone has to go recertify them. These bikes are already on the road. Who's liable for the recertification? Is it the end user? Is it the company that provided them? So these are my takes. There's a lot of unknowns in there. In a nutshell, the way things stand on two-wheelers, at this point, it just does not make sense. I think customers are much better off buying a new bike. It will cost them pretty much the same as converting their bike. There's a negligible price difference. They can easily get financing on it. And from purely an industry point of view, this is very easily scalable. We've been doing it. We put out 2 million motorcycles every year. So there's no reason why we shouldn't be able to do this on EV. And we've already seen the electric scooter companies putting out, thousands of units per month already. So scalability is certainly not a challenge. Now, how it works out on 3 and 4-wheelers, I'm not aware. I mean, that's not something that I've researched or worked on, but on 2-wheelers, we have gone through these numbers and it does not make sense, either for the end user or for the company doing it in the first place. There's really very little value to be ascertained from that process. So that's all I have. I mean, I'm happy to take your questions if you guys want.
Thank you so much, sir. Indeed, the kind of effort being done by you is commendable. And I wanted to ask, what kind of legislations do we need to ease this whole process of conversions? What do you think? हमारा नेट दूसरे लोगों से पूछेंगे Could anyone please confirm if I am audible?
Yes, Merosh, you are audible.
Thank you. I think there is some issue with Ali Saab's internet. Next, I would like to invite Dr. Kalimullah from the Directorate General of Science and Technology, Government of KPK. He has hands-on experience in converting three-wheelers, rickshaws to electric, and he will share practical lessons from the project. Dr. Kalim, please continue. Thank you.
Thank you, Mehrush. Am I audible?
Yes, sir.
Okay. I'll share my slides.
Yes.
I've shared my presentation, so is it fine, Mehrush? Are you seeing the presentation slides which I've shared?
Yes, sir.
Okay, thank you. So basically, I'll take a start. I'm Dr. Kalim from the Directorate General of Science and Technology, Government of Khyber Pakhtunkhwa. And I'm here to present the outputs of the project that has recently been conducted jointly by the Directorate General and the UET Peshawar with a commercialization partner of the Green Volt technology. So the project was the implementation of the EV Raksha in Khyber Pakhtunkhwa, and this project is now a baseline for the conversion of approximately 200,000 rakshas which are currently operating in the Khyber Pakhtunkhwa. So these are the basically the objective of the project was to develop a new EV rickshaw and to convert the existing rickshaw into e-rickshaw. The project has been executed basically in different steps. First, through the technology transfer, it has been a model has been procured, and then that has been studied and reverse engineered. And basis on that reverse engineering, currently gasoline rickshaw has been retrofitted to convert it into the e-rickshaw. So these was the steps. The baseline model or the converted model is shown here. We have basically developed an e-rickshaw that has some features, additional features along with the normal conventional EV systems. That include swappable batteries, battery management system, digital display systems, and ride-hailing app like in Drive app. And these has been developed. The technical features of the rickshaw was the same like 120 kilometer mileage, and it has a high speed of almost 65 kilometer per hour as per the actual drive, and a charging time of 3 hours. We have proposed some charging cabinets along with the conventional charging systems, and that I will show in the later stage. So this was the model which has been reverse engineered. Now, if I see, we can see that the actual retrofitting that has been performed. So from the technical perspective, if we see, uh, I will focus or I'll make my focus on the EV rickshaw because the project was specifically for the EV rickshaw. So if we see the components that has been used in the retrofitting, that is divided into two portions. One was the power and electrical system, and the other was the chassis structure and the mechanical parts. So in the electrical system, there were motors and controller, charger, lithium-ion swappable batteries that which has been proposed, and we have already used the charging cabinet as it is shown in the picture. Basically, the charging cabinet is a swappable type of concept that we have proposed and we have implemented. So usually a normal charging battery takes 7 to, or we can say 6 to 7 hours. So this is not feasible if we convert almost 20,000 plus rickshaws. So it's not suitable to charge all the rickshaws simultaneously or all tricycles simultaneously from any charging stations. We need to have some swappable concepts. So that is why we brought this concept of charging cabinets that can support at the same time 6 batteries or 12 batteries or 24 batteries. We have almost 3 variants of these charging cabinets. On the other side, we have the pictures has been taken basically from the real-time conversion which was taking place. We have integrated differential axis that axle has been used, a gearbox, and the chassis structure and tires. The chassis structure and tires which are shown actually in this picture, has been taken. A normal gasoline rickshaw has been considered and it has been converted. I'll just play this, try to play the video. However, I'll not be able to play it. I think so. So this was the technical perspective of the retrofitting. If I see the financial perspective, so we can see that when we procured the rickshaw or the tricycle as a whole from abroad, so there were different taxes and import duties, and the cost of a single rickshaw reaches to, or single tricycle reaches to almost 1.2 million, which I think is not affordable for anyone to in Pakistan or specifically in KP for anyone or low income family who can afford it. On the other hand, when we procured a set of the conversion for converting the gasoline rickshaw. So we only needed two things. One is electric motor and the other one is the battery packs. And we just brought the battery cells. We developed a controller for it. We developed a charging system. We even developed a battery management system. This has been done with the help of the Energy Center, US-Pakistan Center for Advanced Study in Energy, and they helped us to develop this battery management system. So majority of the other equipments have been managed locally. The cost has been decreases by 65% if we compare it to the actual import of the EV rickshaw. Now, this was the financial perspective. If we see the social perspective, uh, almost a survey has been conducted under this project. And in this survey, we interviewed almost 150 plus rickshaw driver. So if we see the gasoline rickshaw monthly earning, fuel charges, maintenance charges, take home,
Dr. Saab, I think there is some problem with your internet. Could anyone please confirm?
Yeah, we can hear you. We just can't hear him.
I think there is some problem with Dr. Kalimullah's internet. So let's move to our next speaker. Uh, our next speaker is Mr. Adil Irshad, Chief Operating Officer, EV Technology, Sir International Investment Group. The company has been actively working on EV retrofitting and clean mobility solutions in Oman and UAE, building practical models that can be replicated in the region. Mr. Adil will share his expertise and give us a regional perspective from Oman and the Middle East with insights on how these initiatives can guide Pakistan's own EV transition. Mr. Adil, over to you. Thank you. Sir, please carry on.
Assalamu alaikum. Thank you so much, all of you. Good morning to all of you, ladies and gentlemen. Thank you, Merosh, for this invitation. My name is Adil Irshad. I'm the Chief Operating Officer for EV Technology based in Muscat, Sultanate of Oman. For the past 9 years, I've been spearheading all the projects, operations of electric vehicles, charging solutions, so where we have partnered with Star Charge, Schneider Electric, Go2U in terms of software, Navy Parking for digital parking solution, and Zoom Gold for last mile electric delivery solutions for e-bikes. Interesting topic, retrofitting is very rare topic. Not many people talk about it. Not many people are practicing it globally. So this is something I would like to talk today to you guys in theory. that how does it work, why do we need it, etc. So why retrofitting matters? If you could drive your favorite car on electricity, why wouldn't you? First question is this. So EV conversion, meaning replacing ICE powertrain with electric drive system. We all know about it. What are the drivers? Why do we do that? Sustainable goals, rising fuel costs, classic car preservation, fleet efficiency. What the industry says about retrofitting. So when you talk to them, when you talk to engineers, they say, why buy a new car when you can rewire the old? The financial guy says, wait, you mean cheaper than a new EV? Tell me more about it. So regulator says, let's make this sure that doesn't turn your Corolla into a spaceship, because regulation, compliance, homologation is a very long, lengthy process. And when you come to the environment, they say, yes, please, one less car in the junkyard. So car lovers, of course, they're always into transforming their own car. So classic ride can go electric and still turn heads. So once they're in, they're in. Let's talk about global contracts and market drivers. Decarbonization targets, city clean air zones, and fuel economy policies are increasing interest in retrofit solutions. Supply chain constraints, affordability gaps, and second-hand markets make retrofitting an attractive option in many regions. Retrofitting also spans distinct markets, classic car collectibles, light commercial vehicles, van, pickup, motorcycle, buses, and specialized fleets. Now, who benefits from it? First of all, consumers who are the lower cost entry to EV ownership. They have a low cost entry to EV ownership, keep beloved vehicles. Fleets, lower TCO, predictable range use case customization, fast policy compliant. Communities, they get local job, reduce scrap and waste. Industry, new revenue stream for OEMs, conversion specialists, battery recyclers, etc. Now, possibilities of EV conversion. First of all, first possibility is you have a classical collector's car, you preserve the heritage. Second, you have a modern car, extend life, eco-friendly. Fleets, of course, vans, buses, taxis, very high utilization, so you have a strong ROI. 2 and 3 wheelers, which is again a case study for Pakistan. 2 and 3 wheelers, quick, affordable conversions. Conversion kits, standardized retrofit packages. Battery upgrades, hybrids to full EV. How conversion process? How does it work? So conversion process, feasibility design first. Then you have a part sourcing, of course, mechanical integration, electrical wiring, testing, and validation, regulations and compliance, approval and certifications, registration and insurance update. Legal and regulatory landscape. How does it work? What is the legal aspect of it? This is very important to know. Key legal topics to consider by jurisdiction. First is vehicle type approval and homologation. How converted vehicles are certified for road use. Safety standards, very important. Crashworthiness, high voltage safety, battery containment, emission and tax treatment, insurance and liability, intellectual property and OEM warranties, use of proprietary components. Then you have typical regulatory parts, bolt-in kits conversions. How does the path work for the regulation authorities? Bolt-in kit conversion, often simpler, rely on approved components. You have full remanufacture, treated like a new vehicle. Component swap, hybrid path where OEM approve modules, certifications, regulatory takeaway, early engagement with local transport authorities and accredited testing houses shortens your time period. Now, technical approach, main architectures. Who are the main architectures for this? Replace powertrain only, for example, motor, inverter, and battery, minimal body changes. Platform swap, replace entire chassis, drive unit for modern EV platform. Integrate rebody, bespoke builds. What are the common components that you do in retrofitting? Electric motor inverters, battery pack, of course, BMS, DC-DC converter, onboard charger, power electronics, motor controllers, AUX electrics, HVAC electrics. Now, engineering challenges and the solutions of it. What are your engineering challenges when you're retrofitting an EV? Weight distribution, batteries change vehicle mass and center of gravity. Cooling and thermal management. Batteries and motors need active systems. Now, integration with legal systems. integration with legacy systems, your brakes, your steering wheel, instrument clusters, high voltage safety, isolation, containment, range and packaging, very important. Sizing battery for weight, for example, space and target range, practical solution, modular battery packs, use of OEM components. Safety standards and best practices, technical part, again, technical point of view. You have to follow some international best practices because of your homologation, because of your certifications, whichever region or a part of the world you live in. So UNEC regulations are there where applicable. ISO certification also there for retrofitting. IEC 61851 is also for charging interfaces and local homologation directives. Establish your test protocols, HV isolation test, documentation, full bill of materials, BM, wiring diagram, test certification. These are technical safety standards, best practices globally. Financial models and cost breakdown. Now, typical cost elements for a conversion. First cost is your labor engineering, then your battery module, motors, vehicle specific parts, certification, example, order of magnitude, illustrative only. Small city car conversion, for example, you can reach to 8K to 25K. Classic car bespoke premium conversion where you have vintage cars, it can reach from 40K to 200K plus. Light commercial van conversion can reach from 20K to 80K. These are just for illustration purposes. So the figures are just for making you understand. Financial models, ROI and value proposition, which is very important. Why would you do a business when there is no ROI value proposition in it? So TCO focus for fleets, fuel saving, lower maintenance, your operating cost prediction is very important. Residual value can increase for well-done conversions. Incentives and grants, crucial in many markets to bridge upfront cost gap. Business models, outright conversion, how you can propose or go into a business model, outright conversion, batteries as a service, lease to convert, conversion as a service. So there are 3-4 business model you can go in terms of value proposition for your greater ROI. Market barriers. Now, what are the market barriers? Regulation uncertainty and uneven standards across jurisdiction. This is very important part because a lot of car companies, they go through homologation, certification, compliance of every region. Battery sourcing, safety concerns, and recyclability, again, a very important part. Perception. Classic pursuit oppose removing ICE authenticity, insurance complexity, and resale valuation. Quality variance among conversion provider, risk of reputation damage for the sector. Global success stories and case studies. What I have done here is that I've just collected some of the case studies that is good to look at. So maybe your viewers can look into these companies. So let me present a mix of companies and projects. Electric cars, electric classic cars in UK, scaling conversion kits and shop conversions, Zero Labs in US, EV West again US, conversion kits, community engagement with OEM collaborations. They have Z Electric, again a US company, RBW Spirit EV, again it's a UK company. So each case has its unique lessons to learn and practice in its regional capacity. Of course, you cannot just look at the project or how they're doing in US or UK or EU and you copy paste in Pakistan. Each case has to have its unique lesson and practice as per its regional capacity. Now, example of case studies, for example, how we can start one. Owner fits a 60 kilowatt battery, 40 kilowatt battery, range is 150, 200 kilometer, keep stock gear as a fixed gear, install BMS and DC-DC converter. What is the result? You have a vintage look with modern drivability. Your cost is 12K to 30K depending on battery choice and labor. Here I'm not comparing about the economic, socio-cultural factors of Pakistan. Here we're just talking about a general case, how you can build one as a case study. Now, urban delivery scooter conversion, replace ICE scooter with 3 to 6 kilowatt hub motor and modular removable batteries. Lower cost again, quick ROI due to high utilization. Multiple bus municipal bus pilot. Retrofitting a bus with battery pack electric drive can be complex because of this weight and structure. But some programs convert older buses as pilots for depot charging and proven routes. What are the pros and cons? Again, everything in the world, every project I've gone through for the 9 years has pros and cons. So what are the pros for this? Faster emission reduction for existing vehicle stock, new business opportunities, local jobs, preservation of culture, your collector assets, your collection of cars, multiple business model and customer segments, cons, regulation, fragmentation, uncertainty, one of the biggest high initial capital for batteries and testing, variable quality and consumer confidence risk, insurance and legal complexity. Now, what are your operational considerations for scaling the projects, this kind of project? Standardize modules and create bolt-in kits wherever it is feasible. Build partnership with certified battery suppliers and BMS providers. Establish testing and certification flow in target markets. Set after-sales support and battery replacement recycling program, which is very important. Transparent documentation to satisfy insurance regulators. Why retrofitting is vital for Asian countries? This is another big question. High ICE vehicle stock. Asia has a massive base of two-wheelers, three-wheelers, and used cars still running on ICE. Retrofitting these segments can deliver fast results compared to waiting for the full EV penetration. Entrepreneurship and job creation. Retrofitting industries create local jobs for mechanics, workshop, and technicians. Asia, with a strong auto market ecosystem, is well positioned to scale retrofitting businesses. Now, fleet applications, ride-hailing services, last-mile delivery solutions, and public transportation dominate Asian countries. We know that. Converting your autos, buses, and small commercial vehicles can lower operating costs and attract government and private sector buy-in. Retrofitting in GCC. So how retrofitting works in GCC? GCC position countries. GCC positions itself as leaders in innovation and sustainability while diversifying its economies. So retrofitting in EVs is an emerging in the GCC, driven by government sustainability initiative and need a diversity for the economy diversifying the economy from oil into transformation and innovation. Companies like Fuse we have in UAE that is focusing on converting classic cars to EVs that preserve heritage while reducing emissions. Challenges include integrating charging infrastructure into existing areas and general lack of localized skills. But the overall trend is growing, supported by the investment in local EV manufacturing and charging network. Focus on Pakistan. We're talking about Pakistan because the subject is for Pakistan. Affordability. New EVs are beyond reach for most Pakistani consumers. Retrofitting motorcycles, rickshaws, and used cars make electrification possible for the mass adoption towards EV adoption. Urban pollution. Cities like Lahore and Karachi face hazardous air quality. Retrofitting rickshaws and buses can immediately cut the emissions. Local workshop and talents. Pakistan auto repair and modification culture is very strong. Retrofitting could empower SMEs and startups. Energy strategy. With rising fuel import costs, shifting even a portion of vehicles to electric reduces foreign exchange pressure, with boosting demand for renewable energy. Retrofitting is not just a measure, it's a strategic level for Asian markets. Pakistan provides an affordable, scalable pathway to adoption, tackling pollution and energy dependence. By embracing retrofitting, these regions can leapfrog challenges and set a global example of sustainable transformation and innovation. Importance of retrofitting in the present EV market. Now we're talking about in the present EV market, where do we stand? Bridging the affordability gap. Brand new EVs remain expensive for many consumers in Asia and the Middle East, especially where subsidies are limited. Retrofitting existing vehicles with electric drivetrains allows individuals access to EVs. This makes electrification accessible to middle-income population and small businesses that cannot afford brand new EV fleets. Accelerating EV emission reduction. Asia is home to some of the world's most popular polluted cities, as we know: KL, Indonesia, Philippines, Thailand, Delhi, Karachi, Lahore, Riyadh. By converting these existing vehicle stock into EVs, retrofitting can deliver immediate air quality improvements. Retrofitting older fleets like taxis, your delivery vans, buses can also cut urban emissions and noise pollution. A circular economy and resource efficiency. Producing new EVs requires, of course, mining, shipping, and energy-intensive manufacturing. Retrofitting extend the useful life of vehicles already on the road. Aligning with circular economy principles, that's a big sustainability win. Filling the infrastructure gap. Many Asian markets, especially in South Asia, lack widespread charging networks. Retrofit EVs can be customized for local range needs, for example, short urban trips, fleet vehicles, last mile delivery solutions, reducing dependence on fast charging infrastructure until network matures. Now, what can we do now? What are the next step? Decision framework, of course, is a conversion right for you? This is the first question. Personal heritage reasons, conversion makes sense for collector cars or sentimental value, yes. Commercial fleet economies, high utilization fleets are ideal candidates. Availability of new EVs, where new electric vehicles are cheaper and available, conversions are less attractive financially. Regulatory environment, permissive and supported legal frameworks increase viability. Access to parts and expertise must have a reliable supply chain and trained technicians. How is the way forward? Select a pilot vehicle, okay, one van or classic car, and run your feasibility study. Get a local regulation guidance from the transport authorities about inspection and registration requirements, certification, homologation requirements. Create a detailed cost model with labor, parts, certification, downtime, and run the CCO for 5 to 10 years. Engage an automotive engineer, which is a must for structural and safety. Sign off, source components from reputable suppliers for your long life of your parts and vehicles. Train staff and set up safety protocol for your HSE before beginning your high voltage work. So in a nutshell, EV retrofitting enables affordable electrification by repurposing your ICE fleet into efficient EVs, a scalable pathway to reduce emissions without the production of your new electric vehicle. So thank you so much. If there's any Q&A. Hello.
Thank you so much, sir, for your valuable insights. I wanted to ask what regulatory approvals are required for EV retrofitting in Oman, and are there any incentives or subsidies for EV conversion in your country?
Thank you so much. See, when you talk about the GCC, it's an oil-rich economy. So financially, economically, it's a rich state. A lot of people can easily afford more than one EV. Yeah. So retrofitting is still not in fashion. Yes, there are two companies doing retrofitting in UAE, and again, they are doing the collection of cars for the car collectors, for the antique cars. In Oman, it's on a personal scale, on a very low scale, not on a corporate level.
Okay. Thank you, sir.
Is there any question anyone has?
We will also be taking questions from the participants, but those will be addressed at the end of the session. So our next guest speaker is Mr. Muhammad Ali. I'm pleased to invite Mr. Muhammad Ali, Deputy Director, Technical, PSQCA, Pakistan Standards and Quality Control Authority. He will speak about the importance of technical standards and regulatory frameworks for safe and reliable retrofitting in Pakistan. Mr. Ali, are you here?
Yes.
Okay. Over to you.
Islam.
Thank you.
Am I audible? Am I audible to all?
Yes.
Yes. First of all, Assalamu alaikum and good afternoon to all. The topic of today's webinar is exploring EV conversion. A look at the legal, technical, and financial aspect of retrofitting in Pakistan. There are so many questions before me regarding the regulatory framework. So I wanted to move directly to what are the standards or technical regulations which are used or being used or in working around the world. First of all, UNECE, United Nations European Commission, Economic Commission for Europe, is it's WB29 GRPE. It is working party on pollution and energy, and they are currently working for the harmonization of standards regarding the retrofitting systems. As far as PSQC is concerned, we have been working in the past in I think 2021 and adopting two standards, UN R100 and UN R136. That not directly covers the retrofitting regarding EV bikes or rickshaws, but they cover all the major parts about that, just like battery and chargers and other things. So, before that, it is also worth to mention that the technical regulations regarding the retrofitting is not being adopting as yet. There is a difference between standard and technical regulation. Standard is voluntary in nature, and technical regulation is mandatory. So before we can move on to retrofitting or any other things like that, we firstly has to notify it through government or cabinet. First of all, they approve, then we can inspection and certify those products which needs to be retrofitted. There are other standards worldwide which are used for retrofitting. They do not directly covers, but they use just the parts, and they rectified or retrofitted, and just like an example in India, where are the automotive industry association, they develop AIS 123 standard, which is being used there. In India, we can help from that standard as well. So these are the some of technical regulations which are under consideration or under use worldwide. The next step, which I want to mention, that what are the measures we can take regarding the retrofitting policy. There is a need of legislation in Pakistan, such as for example, there is National Electric Vehicle Policy which is in place Pakistan right now, National Electrical Vehicle Policy 2025 to 2030. They do not as specifically mention regarding retrofitting. First we have to acknowledge it, whether it is serves the purpose for the retrofitting or like Pakistani market. The official legislation is required. Then coordination between the different departments, such as EDB, which is responsible for the National Electric Vehicle Policy, and PSQCA, which is responsible for the development of standard. And the main point is, when we retrofitted a two-wheeler or three-wheeler, we require re-registration for that. That are the main questions, and training and awareness. What are the strategies of government institutions regarding the retrofitting? This is an early stage for market like Pakistan. So, a unified regulatory framework, I suggest all the stakeholders such as ED, BPS, QCA, excise need to be incorporated for a better policy or regulation regarding the retrofitting.
Thank you, Mr. Ali, for your valuable insights. Now I would like to invite Mr. Fahim, CEO of Zeus Energy Private Limited. The company is primarily a solar energy solutions provider, but it has shown a keen interest in EV conversions and is also exploring the supply chain for EV conversion parts in Pakistan. Mr. Fahim will share his insights on EV retrofitting and the role that private sector can play in making this transition viable. Mr. Fahim, the stage is yours. Please continue. Thank you.
Okay. Hello. I would like to share my screen. Screen share. Where is screen share option? Chat. Okay. So so share kind. Share. Okay. Share screen. Okay. Now you can see my screen.
Yes, sir.
Okay, so my company is a engineering service company. We are PSU, PECC2, and with EV we are too much interested. So last we are working with the few manufacturers of EV components and EV manufacturers in China mostly, and we have make a research design collaboration agreement with those companies for EV rectifications and EV component in Pakistan. So in Pakistan, there are two approaches to EV rectification that I have seen so far. One is the using of old battery in EV retrofit. In that approach, the people are using hybrid and EV battery pack and motors for the retrofit. And this is very easily converted and it cost is very low and the ROI is better. And the acceptability is more. Why people are choosing this kind of approach is that it is readily available. What the problem which I see in that is a reduced capacity and range because it is already used battery. There are sometimes unreliable performance and sometimes safety hazard and BMS compatibility issues can rise. And weight and space and shortened lifespans is also there. As for the new component design concern, when somebody come and they say they wanted to have a EV rectification, the design can be totally designed according to that person. The range can be from 100 kilometer to 700 kilometer defined on that client. So we are making the product specific for that model. The vehicle design is by the expert engineer. New battery pack, VCU, thermal management, reliable performance, and now we are also considering to have a range extender in few of the models. Point to consider in the EV rectification is the vehicle condition. What is the cases, suspension, brakes, brake torque, motor selection, what kind of a motor you are doing either in the vehicles or in the bikes. Battery pack that I mentioned already, the kilowatt range and its weight placement. And if you require more range, you will increase the battery pack. Controller, you will write to have all the system that is integrated and all the system. The most important thing in this is the cooling system, air and liquid cooling for motor controller and batteries. Charging system and in the new component, we can also have the fast charging and stroller breaker. As for the EV bike retrofit, it is a little easier part. We have a hub motor or mid-drive motor, controller, handles, and battery pack, wiring, brake system. This is some of the components that can be used, that is used for the EV retrofit of the e-bikes. This is an estimated cost of the e-bike retrofitting. And we are doing another project. In that project, we are making a 18-wheeler truck to EV. So we have designed, given the whole detail of this project to the manufacturer, and we are working with the manufacturer to retrofit this project, in which we will be replacing its major components and all the designs. And it will have the battery pack, battery management system, all the axles and everything will be replaced. Engine drive carburetor and AC system will be done. The gearbox suspension systems will be shift and the braking system. Modification, there would be some modification required in that EV trucks. An electric drive system would be converted to have that thing. And we are using, in this project, we are using cattle battery to be replaced. And this is our estimate of what we were doing. We have calculated the cost of the consumption of our client, and we have estimated around $31,000 saving per annum for the retrofit of that EV truck. So we right now are working on the few projects in which we are doing this retrofitting, and mostly we are working with the manufacturers to have the conversion on them. So that was a very short, because as far the problems concerned and everything, persons before me explain much better, and they are the research associates and they have explained everything in very detail. So if there is any question, do let us know.
Thank you so much, sir, for your valuable insights. Sir, since heavy vehicles like trucks require heavy safety standards, high safety standards, so how will you ensure the road worthiness of these converted electric trucks?
We have signed an agreement with the bus manufacturers in China and the vehicle truck manufacturers. So we are in fact using the chassis. The thing is that when we like for example, if a person want to have a truck and he want to in Pakistan right now there is not too many infrastructure of EV. So if the person have to drive 500 kilometers, so we can ask the client to have 2 points, and we have the charging in between them, and we have can be the customized. And there are a lot of construction sites. For example, we have a few clients in which their daily consumption or the range is just 100 kilometer and 150 kilometers. So for few clients, the range of the battery pack would be less. So we will be doing all the thing, and we will be only using the chases and the other thing. If we bring out the new product, brand new, all the product, the costing and the taxation would is so high. So we can only do the ROI of the project if the this system fitted. As far the legal is concerned, we will be after the completion of the project, we will consult the legal department and let them see how to vet it. I have met with the Punjab authority, one of them, and they said apparently they do not have any objection on that. Transport authority, because they were saying that they were mostly concerned with the safety concerns and the fuel emission. So for EV, we need to have the more, when our project will be complete, then we will see how to take it that.
Thank you, sir. Sir, is currently what are the biggest supply chain challenges you are facing for EV conversion parts in Pakistan?
Problem is that there is not too much EV conversion. So we are, for example, either people are using old products, and for the old products they do not have the proper controllers and the management. So what we have done is that with different vehicles we have connected with the relevant manufacturers and bringing them to Pakistan. The conversion ratio in Pakistan is very less, so it is a very high taxation, and the cost of import, for example, if we import few unit like 10-20 unit, the cost is less. If we import 100 unit, the cost is much cheaper. So the cost of EV conversion right now in Pakistan is higher in the vehicle sector as compared to other. So the lead time is a little high as compared to readily available stocks. We have sometimes we have the few units available, but the lead time is a little higher. We need to plan ahead.
Okay, sir. Thank you.
But the motors, what we are planning to do in 1 month time or 2 month time, we are planning to have lot of motors that is not for the VCU, but lot of motors readily available for the BLDC, and some other that is for Bolan, and some other components we wanted to have some stock available for the easy for 10 to 15 kilowatt EV kits. We are planning to have few stock available in readily available for the people, for us, and for other people as well.
Thank you so much, sir, for your valuable insights. Next, we have with us Dr. Muhammad Iftikhar, CEO of Farmers Way Private Limited, a leading agriculture solutions company in Pakistan, providing irrigation and farming technologies to empower farmers. Dr. Iftikhar is also an investor who is interested in EV conversions, exploring ways to electrify diesel-powered agricultural machinery such as tractors and other equipment for sustainable rural mobility. Dr. Iftikhar, kindly share your views. Sir, are you available?
अस्सलाम वालेकुम।
Welcome, assalam.
जी जी मनोज बेटे थैंक यू जज़ाकल्लाह। मैंने ये चीज़ें सारी सुनी हैं, जितने भी दोस्त हैं इधर। देखिए ये तो सारी चीज़ें आप जैसे जो इंजीनियर्स लोग हैं, ये आपके लेवल की चीज़ें हैं। हमारे लायक जो है ना वो हमें बताएं। जिस तरह हम एक अपना कॉन्सेप्ट लेके आए हैं नेट ज़ीरो कार्बन का, नेट ज़ीरो कार्बन क्लाइमेट चेंज बेस है ये सारा, और फ्यूचर फूड सिक्योरिटी बेस, सेल्फ सस्टेनेबल है, इकोसिस्टम इंटीग्रेटेड, प्रोडक्टिव, ऑफ द ग्रिड, एलीट एग्री स्टेट्स हैं। देखिए जब कार्बन एमिशन की बात होती है ना, तो बहुत ज़्यादा जो अपना शेयर काउंट किया जाता है वो एग्रीकल्चर से आता है। हम एग्रीकल्चर के एमिशन पे काम कर रहे हैं, और इसमें फिर एग्रीकल्चर के एमिशन में फिर सारी इसकी मशीनरी, फार्म मशीनरी, ट्रैक्टर्स और ये इसकी व्हीकल्स ट्रांसपोर्टेशन एग्रीकल्चर में जो इस्तेमाल होती हैं, हम उसको जो है ना अपना ये फुटप्रिंट फ्री करना चाह रहे हैं। तो इसी पे हम जिस तरह रिन्यूएबल एनर्जी और अपना फुटप्रिंट रिडक्शन और कार्बन कार्बन कैप्चरिंग पे हम काम कर रहे हैं ना जिस तरह,
जी जी।
तो आप जैसे इंजीनियर लोग हमें सोल्यूशन दें कि आप लोगों को हमसे क्या सपोर्ट चाहिए। हम मिनिस्ट्री से आप लोगों के लिए क्या अप्रूव करवा सकते हैं, अथॉरिटी से क्या अप्रूव करवा सकते हैं। जिस तरह अभी ये हादी साहब मेरे दोस्त भी हैं, हादी साहब ने मुझे बहुत अच्छा गाइड भी किया है कन्वर्जन पे, इन्होंने हमें कन्वर्जन करके भी दी हैं। लेकिन देखें जिस तरह ये हम ये चीज़ें मंगवाते रहे हैं, कभी ये अपना बॉर्डर के मसले बन जाते हैं, कभी इंपोर्ट के मसले बन जाते हैं, कभी टैक्सेस के मसले बन जाते हैं। आप इस तरह के जो प्रॉब्लम है ना वो हमें लिख के दें, हम आप लोगों को उसमें हेल्प आउट करते हैं। तो फिर आपको हम एक बहुत अच्छी बड़ी फैसिलिटी देते हैं, प्लेटफॉर्म देते हैं कि जहाँ पे सिर्फ एक हमारा प्रोजेक्ट ही, जिसमें को हमें 1100 से ज़्यादा तो हमें गाड़ियाँ चाहिए इलेक्ट्रिक कार्स, जिनको आप कन्वर्ट भी कर सकते हैं, या कोई इस तरह मैन्युफैक्चरिंग में ये कोई नई हमें आप कोई इस तरह की वो वहाँ से मंगवा के दे सकते हैं। हम ये फैसिलिटी हम आपको अवेल करके दे सकते हैं। ट्रैक्टर पे काम करें, जो पुराने ट्रैक्टर हैं उनको कन्वर्ट करें। इसी तरह ये लोडर है, इनको कन्वर्ट करें या कोई नई इस तरह की चीज़ हमसे इस तरह को काम लें। मतलब जो ये एमिशन रिडक्शन है इस पे और कार्बन कैप्चरिंग पे, ठीक है ना, इस पे हमें कोई पॉलिसी को इस तरह के अपने मामला लिख के दें, हम आप लोगों को अप्रूवल जहाँ पे हर्डल्स हैं, जहाँ पे मामला हैं, हम वो डिस्कस करें अथॉरिटी से, तो आप लोगों को ताकि उसको फैसिलिटेट किया जाए, आप लोगों को अच्छा प्लेटफॉर्म जनरेट करके दिया जाए जहाँ पे आप सारे एक्सपर्ट, सारे जीनियस एक अपनी चीज़ें उसको आप जो लोगों को बना के दिखाएं इस पे मिशन रिडक्शन पे जो प्रॉपर आप हमें काम करके दें। तो ये है जो हम आपके लिए कर सकते हैं। और इसमें मैंने जिस तरह हादी साहब को, मैं रोश बेटे आपको सबको हमने प्लेटफॉर्म भी दिया है, सारी मामले भी किए हैं, लेकिन आप अपने प्रॉब्लम बताएं हमें भी, आपको कहाँ कहाँ पे प्रॉब्लम्स हैं और हम उनको किस तरह कैसे आपको उसके सोल्यूशन अथॉरिटी से करवा के दे सकते हैं। जी
May I ask a question, Mel?
जी
Thank you, sir. Actually, I am from I'm representing the Directorate of Science here. और आपकी बातें जिस तरह आपने एक्सप्लेन की, सो दैट हेल्प अस अ लॉट। इस वक्त चूंकि इन द नेक्स्ट वीक वी हैव इनॉग्रेशन, फॉर्मल इनॉग्रेशन फ्रॉम द चीफ मिनिस्टर खैबर पख्तूनख्वा। वी आर एक्चुअली अ प्रोजेक्ट हैज ऑलरेडी बीन प्लान और एग्जीक्यूटेड के जिसमें फर्स्ट फेज में हम, एज आई हैव मेंशन्ड, 90,000 गैसोलीन रक्शेस को केपी लेवल पे अब कन्वर्ट किया जा रहा है with an annual conversion plan of 10,000 rakshas. Now
yes
the government is basically working on the iski jo to claim the carbon credit for this conversion. In that regard, we are basically searching for the experts and specialists to help us that how we need to claim the carbon credit, how we need to go, and how we need to develop a policy. इस पर केपी गवर्नमेंट ने अपने एक पॉलिसी भी बना दिया है तकरीबन, that has been prepared ड्राफ्ट फॉर्म, जो कि मैं आपके साथ शेयर भी कर सकता हूं, एंड आई कैन टेक द कमेंट्स, योर कमेंट्स। सो इन दैट रिस्पेक्ट वी वुड नीड योर हेल्प।
जी। अच्छा,
जी
इसमें जब हम कार्बन क्रेडिट की बात करते हैं ना जी, देखें, जब देखें पाकिस्तान में तो अभी तक कार्बन कैलकुलेटर ही इंस्टॉल नहीं कहीं हो सका ना, ये यहाँ पे कोई इसको डिजाइन कर सका है। और दूसरे नंबर पे जब हम कार्बन क्रेडिट की बात करते हैं तो यहाँ पे वो स्टैंडर्ड अभी को है जिसने ये गोल्ड स्टैंडर्ड इसके अपना ये इसकी सर्टिफिकेशन में या अप्रूवल में गए हैं, किसके पास हैं वो? आपको कौन किस तरह ये अपना क्रेडिट ये आप उसको क्लेम कर सकते हैं जी?
कार्बन क्रेडिट
जी
सर,
जी मैम।
कार्बन क्रेडिट्स वाला जो फ्रेमवर्क है वो तो मिनिस्ट्री ऑफ क्लाइमेट चेंज एंड एनवायरमेंटल कोऑर्डिनेशन के उनके अंडर आता है, जो कार्बन एमिशंस कितनी कम कर रही हैं ईवीज और कितना कार्बन फुटप्रिंट कम हो रहा है, ये उस मिनिस्ट्री के अंडर है।
Can I
नहीं,
add
मेरी
something?
मिनिस्ट्री में गालबन एक खातून है, पता नहीं क्या खालदा के, पता नहीं क्या नाम है उनका, मेरी उनसे भी मीटिंग हुई है। वो अच्छी, वो 20 ग्रेड की हैं, वो वहाँ पे अपना कोई डायरेक्टर पता नहीं क्या है। लेकिन जो लोग इस पे काम कर रहे हैं उनको ही इसकी बेसिक्स का नहीं पता, तो वो क्या कार्बन कैलकुलेटर किस तरह आप कैलकुलेट करेंगे और किस तरह ये लैंड कराएंगे आप, ये अपना कार्बन क्रेडिट किस तरह लैंड किस तरह कराएंगे, क्या वो उसका अपना गेटवे क्या है आप लोगों के पास, इसका कोई फ्रेमवर्क है, वो गेटवे है, किस तरह आप यहाँ पे देखें। वो गोल्ड स्टैंडर्ड मांगते हैं, वो किसकी रजिस्ट्रेशन है पाकिस्तान में गोल्ड स्टैंडर्ड की कार्बन क्रेडिट के लिए?
Can I add something?
जी प्लीज।
जी
जी
Jamshed Kesrani, I am CEO of Nexel Technologies Private Limited. We are the pack manufacturer of sodium and batteries and the lithium LFP batteries. Actually, EV cars के हवाले से जो mitigation potential है regarding carbon reducing is very challenging. When you are using your car, when you are driving your car, it is not 100% zero carbon. सो हम जो वर्क कर रहे हैं कि हम इस मिटिगेशन पोटेंशियल को 60 to 70% तक अचीव करें, बिकॉज व्हेन यू चार्ज योर vehicle from grid, it's not 100% the electricity is produced by रिन्यूएबल एनर्जी। तो हम इसके ऊपर काम कर रहे हैं, और जो लोग इंटरेस्टेड हैं मेरे से कांटेक्ट कर सकते हैं। हम इलेक्ट्रिफिकेशन ऑफ एग्रीकल्चर मशीनरी उसके ऊपर भी काम कर रहे हैं, और हम रेट्रोफिटिंग के ऊपर भी काम कर रहे हैं। और हम एक फैसिनेटिंग आइडिया दे रहे हैं, बिकॉज योर कार इज नॉट ओनली यू आर रनिंग ऑन इलेक्ट्रिक, बट योर कार इज आल्सो ए स्टोरेज सोल्यूशन। सो आप अपनी कार को इवनिंग के टाइम पे, इफ लाइक 54 किलोवाट की आपकी बैटरी है, एंड you have a drive per day around 100 किलोमीटर, सो आपकी 60 to 70% बैटरीज जो है वो स्टोरेज होगी, एंड यू कैन कनेक्ट विद, देयर इज टू सोल्यूशन, one is V2H, vehicle to home, and another is vehicle to grid. सो इस कॉन्सेप्ट को अगर हम लेके चलेंगे इन फ्यूचर, तो हम इसके मिटिगेशन पोटेंशियल को अचीव कर सकते हैं। थैंक यू वेरी मच।
सर, ये आपने V2G की जो बात की है, व्हीकल टू ग्रिड टेक्नोलॉजी, की आपकी ईवीज जो हैं वो आपके ग्रिड को भी सपोर्ट
अच्छा
करें, तो कोई आपका इसका प्रैक्टिकल आपने इसके ऊपर किया है कोई अभी? क्योंकि
अच्छा
पाकिस्तान
सॉरी
में आई
मैं
डोंट थिंक अभी
No,
किसी ने V2G को
it's a very
इम्प्लीमेंट किया
simple. It's a very simple. Every house right now in Pakistan who has energy storage solution, they have net metering. So you have just connect your inverter with the battery. We will give an external port जिससे आप सिर्फ इन्वर्टर को जो आपकी व्हीकल की बैटरी है उससे कनेक्ट करना है। देन you can use to home, and you can also use to export to grid. It's very simple. Yeah.
अच्छा
बिकॉज
अच्छा इसमें
जिस घर में भी हाइब्रिड इन्वर्टर लगा हुआ है, he can use he can use their battery for home and also to export to grid.
ठीक है।
अच्छा इसमें सॉरी जमशेद, मेरा क्वेश्चन है जमशेद साहब से। आप जिस तरह ये अपने गवर्नमेंट एक कन्वर्जन की बात की है इस पे, अपना एग्रीकल्चर मशीनरी पे,
जी
इसमें हम जो इस चीज़ पे लगे हुए ना, ये अपने तौर पे मैं को थोड़ा तारुफ करवा देता हूँ। मेरी अपना ऑस्ट्रेलिया से पीएचडी है इंडिजिनस एंड रीजनरेटिव फूड सिस्टम पे ना।
that's
तो
great. I'm
ये अपना
electrochemist, and I have
इसमें सारा
research
फूड
in,
सिक्योरिटी क्लाइमेट चेंज भी इसी में आता है।
yeah.
अच्छा जो
सॉरी आपकी आवाज कट गई थी।
अच्छा ये जो आप एग्रीकल्चर ये फार्म मशीनरी की कन्वर्जन की बात कर रहे थे ना जी, अच्छा इसमें हमने कोई 8-10 साल पहले इसके पोर्टेबल चार्जिंग स्टेशन सिस्टम डिज़ाइन करके और अपने ट्रैक्टर इस पे कन्वर्ट करके चलाए हुए हैं। ये जो चार्जिंग स्टेशन है, पोर्टेबल चार्जिंग स्टेशन 20-20 किलोवाट के, ये हादी साहब ने उन सारे लोगों ने देखे हुए हैं हमारे फार्म पे शेखुपुरा और आगे पीछे, ये उधर गए भी थे ये। और जो हमारे मिनी टेलर और छोटी अपना ये स्मॉल स्केल की मशीनरी है 5-5 किलोवाट पे लिथियम आयरन फॉस्फेट पे, हमने उसको अपना ऑलरेडी कन्वर्ट किया, हम उसको चला रहे हैं। लेकिन क्वेश्चन ये है कि क्या यहाँ पे गवर्नमेंट लेवल से कोई इसकी कन्वर्जन की पॉलिसी मौजूद है, या
डॉक्टर साहब ये
उसमें
तो आपको
किस तरह आप
डॉक्टर साहब
इसको देखते हैं?
जी डॉक्टर साहब, ये तो आपको गवर्नमेंट अथॉरिटीज यहाँ पे अवेलेबल हैं, वो आपको कंफर्म कर सकती हैं, बट आई कैन डिस्कस विद यू ऑन द टेक्निकल एस्पेक्ट्स। So we did
हाँ
not recommend LFP battery for the electrification of tractors and dumpers and like these, because जो LFP बैटरी है that is sensitive for the C rating. Like आप मैक्सिमम
हाँ
इस वक्त भी जो सबसे एक्सपेंसिव बैटरी है that is 4C रेटिंग है उसकी, otherwise 1C or 1.5C है. So we are bringing another battery technology, that is the sodium ion. Right now
हाँ
China
जी
में
yes,
China में sodium ion is successfully commercialized, and it has up to 15C. और इसमें ये होगा
हम्म
क्योंकि जो आपकी इलेक्ट्रिकल मशीनरी है, बिकॉज आई एम नॉट मैकेनिकल, आई एम इलेक्ट्रोकेमिस्ट, सो मैकेनिकल जो एग्रीकल्चर मशीनरी है उसका टार्क बहुत हाई होता है, दैट्स व्हाई वी रिकमेंड सोडियम आयन बैटरीज फॉर दोज रेट्रोफिटिंग्स।
थैंक यू
और
सर।
मेरा इस पे एक पेपर भी है, मैं आपको शेयर कर दूंगा।
जी जी,
जी
sure sir. We will also be taking questions from the audience. The floor is open. If anyone wants to ask questions from our distinguished speakers, uh, kindly proceed. Um, I think Hanzala from Star Charge. My question is that does these retrofitted vehicles will also support DC fast charging standards? हंसला साहब आप यहाँ मौजूद हैं?
अस्सलाम वालेकुम जी, मैं अवेलेबल हूँ यहाँ।
जी जी वालेकुम अस्सलाम.
I think I can answer this question if you don't mind.
Yeah, sure.
जी जी please.
Hi, Anjala, how are you doing? Good. We are also the representative of Star Charge for Oman, by the way. So it's nice to
Okay.
see that you are working for
Nice to
Star.
see you as well.
Okay, so the question, see, the first of all, EVs can be charged AC and DC. This is first thing you need to understand. There are some vehicles globally available, especially in China. Those are pure electric vehicles, and they are only charged AC. You need to also know this. There are some vehicles can only be charged AC, which are available in China. Now,
Okay.
let's come to the retrofitting. Retrofitting is all about the capacity of your engine, how much power it has. Like in lame words, I will make you understand. So, as per the capacity, you can have AC charging and DC fast charging. Of course, people prefer DC fast charging because it's fast than AC. But yes, there are cars available, pure electric vehicles, which are only charged by AC. So it all depends on you what kind of capacity you want to put in your car so it can be charged AC and DC. I hope I answered your question.
Thank you very much.
May I
I
add? May I
understand.
add something? May I add something?
Yes, please.
Yes, because Adil sir, जो बैटरी की electrochemistry होती है, you can never charge AC. Actually, you can convert AC into DC and then you can charge the battery. So there are some solutions that you can charge DC with the DC. If you have a high voltage HVBP, high voltage battery banks, then you can charge DC to DC. Otherwise, normally the AC is converted into DC and then you can charge the battery. So maybe ये आपका misconcept हो कि AC से ही charge होता है. There is a inverters.
Yeah,
तो
because
inversion जरूर होगा.
there is
Yes.
an onboard charger that convert AC into DC.
Yeah. Of
Electric
course.
vehicles. Yeah.
We are
इसमें
not
मैं
talking
कुछ
about
ऐड
the
करना
onboard
चाहूँगा.
charge.
बेसिकली जो हमारी डीसी फास्ट चार्जिंग है ये 200 वोल्ट्स प्लस शुरू होती है नॉर्मली. इस तरह आप निसान को देख लें 365 वोल्ट्स पे काम करती है. ऑडी का डिफरेंट है लेकिन अबव 200 होती हैं. तो जो डीसी फास्ट चार्जिंग है अगर तो हमारी जो बैटरी कैपेसिटी है सपोज वो 72 वोल्ट्स की है या 96 वोल्ट्स की है या 144 वोल्ट्स की है तो वो बैटरी किसी भी सूरत डीसी फास्ट चार्जिंग पे चार्ज नहीं होगी. L3 चार्जिंग पे नहीं चार्ज हो सकती क्योंकि बैटरी का साइज छोटा होता है. इतनी जो वोल्टेज की बैटरी है वो डीसी फास्ट चार्जिंग सपोर्ट नहीं करती. लेकिन उसके लिए हम ये कर सकते हैं कि हम हमारे पास कोई अगर कोई वेरिएबल डीसी पावर सप्लाई है और सी रेटिंग बैटरी की अच्छी है. मतलब अगर 1 सी रेटिंग है तो इसका मतलब है कि 10 किलोवाट आवर की बैटरी भी 10 किलोवाट पे अगर चार्ज करेंगे 72 वोल्ट्स पे तो वो 1 घंटे में चार्ज हो जाएगी. 10 किलोवाट एट 72 वोल्ट्स मीन के जी 138 एम्पेयर तक ये बैटरी सपोर्ट करती है. तो ये एक तो इसमें सी रेटिंग इन्वॉल्व है. दूसरा इसमें जो बैटरी की वोल्टेजेस हैं वो ज़्यादा रोल प्ले करती हैं. अब जैसे मैंने भी निसान लीफ की बात की तो उसमें L3 चार्जर की सपोर्ट आती है. इसमें 55 किलोवाट का चार्जर चार्जिंग सपोर्ट करती है. और L2 जो है वो तकरीबन उसके साथ जो जब भी बात होती है ऑन बोर्ड चार्जर की वो 6.6 किलोवाट पर चार्ज करती है. तो आई होप दैट आंसर्स योर क्वेश्चन.
मैं समझा नहीं हूँ क्वेश्चंस. आप ये समझ रहे हैं कि जी आप बैटरी बैंक से ईवी कार की बैटरी को चार्ज कर सकते हैं विदाउट एन इन्वर्टर और विदाउट
नहीं वो
किसी
डीसी
चार्जर
फास्ट
के
चार्जिंग
विदाउट
वो कह रहे
चार्जर
थे
के
कि क्या ये
विदाउट
रेट्रोफिटेड
चार्जर.
व्हीकल्स जो हैं ये
Are
डीसी
you
फास्ट
are
चार्जर को
asking?
सपोर्ट करें.
Let me explain. Are you asking that the fast charging, the fast charging is not like that you have to charge directly with AC without any inverters. तो मैं थोड़ा क्वेश्चन आपका समझ नहीं रहा. You are asking about the fast charging?
हंजिला साहब आप क्या सवाल क्या करना चाह रहे थे. क्या अगर मैं ये कहूँ कि आप ये कह रहे थे कि क्या रेट्रोफिटेड व्हीकल्स जो हैं वो डीसी फास्ट चार्जिंग के स्टैंडर्ड्स को सपोर्ट करती हैं आप ये पूछना चाह रहे थे.
जी जी, मेरा बिल्कुल यही क्वेश्चन था,
जी
लेकिन
जी
आपने
जी जी
उसको क्लैरिफाई कर दिया। आपने कहा है कि अगर हमारे पास बैटरी की कैपेसिटी इतनी नहीं है कि वो
जी
डीसी
जी
फास्ट चार्जिंग को सपोर्ट कर
असल
सके,
में डीसी
तो
फास्ट
ये
चार्जिंग
पॉसिबिलिटी है।
200 वोल्ट्स प्लस पे स्टार्ट होती हैं, तो इस वजह से जो
जी जी, एग्जैक्टली।
L3 चार्जर, जो कमर्शियल चार्जर हैं, वो सपोर्ट नहीं करते।
जी,
यस सर।
दिस वाज माय क्वेश्चन, और आपने
थैंक यू
अच्छा
जी।
एक्सप्लेन किया। थैंक यू वेरी
और
मच।
भी किसी का
कोई
क्वेश्चन है
भी
तो
बैटरी
प्लीज,
हो, उसकी जो
ये
चार्जिंग
इंजीनियर
रेट
एमन
होगा
I
दैट
प्लीज
इज
wanted
ऑन
to.
द
wanted to ask
उसकी
a
इलेक्ट्रिक
question.
उसकी उसकी
Please
उसकी
carry on.
इलेक्ट्रोकेमिस्ट्री पे डिपेंड करेगा कि वो कितनी उसकी सी रेटिंग एक्सेप्टेबल
जी जी
चार्जिंग है,
सर,
चार्ज
जी
एक्सेप्टेंस क्या है उसकी।
थैंक यू सर।
Uh, Assalamu alaikum, everyone. Am I audible to all of you?
यस
Okay, so I am Emin Yasmin and I am mechatronics engineer. And I have seen यहाँ पे बहुत ज़्यादा retrofitting की और electrification की बातें हो गई हैं. But as a mechatronics engineer and I am also associated with trainings of EV and retrofitting, I wanted to ask a question little towards the mechanical aspect of this. Uh, I really want to that we also have the challenges we are facing in this in calculating the center of gravity and weight balancing while retrofitting. So I wanted to ask you all are experts here that what type of softwares and what type of techniques you are using to calculate the center of gravity or weight balancing while retrofitting of the car or trucks and buses.
देखें, जो रेट्रोफिटेड कार है और जो में और जो आइस कार को जो हम रेट्रोफिट करते हैं, तो बेसिकली इसकी सिर्फ प्रोपल्शन में फ़र्क आता है। हम इंजन को रिप्लेस कर देते हैं मोटर से, बाकी गाड़ी एज इट इज़ बिल्कुल सेम रहती है, लेकिन क्योंकि वेट में फ़र्क आ जाता है तो हमें सेंटर ऑफ ग्रेविटी कैलकुलेट करनी पड़ती है। तो सीजी कैलकुलेशन के लिए हमारे पास काफ़ी सॉफ्टवेयर अवेलेबल हैं। और जो इसमें जो दूसरा सबसे बड़ा चैलेंजिंग एस्पेक्ट होता है कि आपने जब मोटर को ट्रांसमिशन के साथ माउंट करना है, तो आपने अडेप्टर प्लेट और कपलर, आपका सिस्टम का डिज़ाइन हुआ होना चाहिए कि ट्रांसमिशन बिल्कुल सीमलेसली उसके साथ माउंट हो जाए। तो सॉलिड वर्क्स यूज़ करते हैं हम डिज़ाइनिंग के लिए, और नेशनल इंस्ट्रूमेंट्स के काफ़ी टूल्स अवेलेबल हैं सेंटर ऑफ ग्रेविटी कैलकुलेट करने के लिए, सीजी कैलकुलेट करने के लिए और वेट बैलेंसिंग के लिए।
सर आई वांटेड टू ऐड कि यहाँ पे बहुत से ऐसे लोग हैं जिन्होंने बात की है कि दे आर डूइंग कन्वर्जन्स लाइक इवन रिक्शा कन्वर्जन्स, इजी बाइक्स एंड दैट आई जस्ट वांट टू आस्क कि ऑलरेडी क्या वो प्रॉपरली एक स्टिमुलेशन सॉलिड वर्क्स की स्टिमुलेशन पे रिलाई करते हैं और समथिंग एल्स?
देखिए, फर्स्ट टाइम तो जब हम स्टार्ट करते हैं तो फिर तो आप कह लेंगे फर्स्ट टाइम तो सिमुलेशन इस तरह डायरेक्टली नहीं हो सकती, कोई फीडबैक आता है उसके बाद फिर हम इम्प्रूवमेंट करते जाते हैं।
यस।
तो लेकिन इसमें ऑब्वियस सी बात है कि टूल्स को यूज़ किए बगैर, तो प्रॉपर इंजीनियरिंग अप्रोच यूज़ किए बगैर तो हम इसको प्रोसीड नहीं कर सकते।
यस सर, यू राइट, बट आई जस्ट वांट टू से कि जिन्होंने ये काम किया है क्या वो बता सकते हैं कि उन्होंने सॉलिड वर्क्स का यूज किया है अपने इसमें कन्वर्जन में?
बिल्कुल।
जी जी, let me answer this thing. Actually, we have actually converted, practically converted this EV Raksha, or retrofitting के बाद we have converted two Rakshas, and now it is in the practice stage. So we are currently modeling that EV Raksha for the center of the gravity, because what we have done, हमने experience इस तरह किया कि हमने पहले retrofitting perform की, and then basis of the feedback now we are seeing that क्या their वेट से कोई फर्क आ रहा है या नहीं आ रहा है, एंड इज देयर एनी एक्स्ट्रा वेट, चेसिस की जो बॉडी है उस स्ट्रक्चर पर किसी जगह पे वेट का जो है वो ज्यादा हो रहा है या कम हो रहा है, दैट इज बेस्ड ऑन द एनालिसिस. सो वंस वी हैव दिस सम काइंड ऑफ फीडबैक, we will be able to then analyze it in the software. But to be honest, इतना फर्क नहीं पड़ेगा जितना we are basically, क्योंकि हमारे पास यहाँ पर रॉ चीज़ें बहुत ज़्यादा है, और यहाँ पर नॉर्मल कन्वर्जन जब स्टार्ट हो जाएगी मास स्केल पर, तो आई वुड नॉट से कि इसके लिए हर कोई सॉफ्टवेयर को यूटिलाइज करेगा. इंस्टेड दे विल मोर रिलाई ऑन द प्रैक्टिकल कन्वर्जन. हाउएवर, जी जी.
But sir, when you come to standards and when you come to certification and standards and everything, of course आपके पास कोई चीज तो होनी चाहिए which can be a reliable thing for this. This
Yes,
is
Yes, basically जो certifications है उसके लिए it is important that you have some standard kind of structure, and that is wholly solely depends on your chassis body, जो कि body है of the जिस पर पूरा weight of the EV vehicle पड़ेगा. So for that it is must कि हम उसको किसी software से जरूरी नहीं कि इस specific software में model करें, because we have so many softwares other and we are
Yes.
experiencing that. So उसमें modeling जरूरी होगी, और चूंकि equal weight distribution के लिए we cannot have anything practically जिससे हमें पता चले. So for that the software is in order to certify this thing, this is important that we model it in the software.
May I add something?
Yes, I can add something since
May
we've
I?
done this in the past. तो देखिए, there is two ways of doing something. एक होता है जुगाड़, जिस पे अनफॉर्चुनेटली पाकिस्तान चलता है, और एक होता है सही तरीका. So even when you take something as simple as a motorcycle जिसको आपने retrofit करना हो, तो it's just not a matter कि जी आपने उसके ऊपर अपनी मर्जी से बैटरी कहीं लगा दी एंड सो ऑन, और कहा के बाद में हम डेटा कैलकुलेट करके देख लेंगे कि कैसा आता है. No, that's not the right way of doing it. So when we started this project about a year and a half ago, the first thing we did was we went and we scanned a Honda CD70 and a United CD70. हमने सारों को स्कैन किया ताकि हम उनके पता लग जाए कि कैसे होती हैं. Then we modeled everything on it. The first thing we did was कि हमने through software उसके ऊपर डिसाइड किया कि बैटरीज कहाँ जाएंगी, उनका क्या वेट होगा, and there's software that will allow you to do that, including SolidWorks. उसके बाद आप उसी के अंदर आप स्ट्रेस टेस्ट कर सकते हैं, उसी के अंदर से आप सेंटर ग्रेविटी आप निकाल सकते हैं. वंस यू हैव समथिंग इन फाइनल इन अ मॉड्यूलर फॉर्म, देन उस मॉडल को जाके आप कन्वर्ट करते हैं इनटू रियल फंक्शनल प्रोडक्ट. दैट्स द राइट वे ऑफ डूइंग इट. तो आई एक्चुअली डिसएग्री कि पहले बना लो और फिर बाद में
Yes,
टेस्टिंग करके देख
actually,
लेंगे
I
कि
was
रिजल्ट्स क्या आते हैं.
also asking this कि जाहिर है कि
That is the way the whole world does it.
Thank you,
ये
जी.
कोई ऐसी चीज नहीं है कि जो मैंने इजाद की है. This is just general engineering principle. This is how the world operates.
Thank you so much, everyone, for your valuable insight.
Can I add some?
Next,
Can I add something?
Azbiya Shakur, I think कोई question करना चाह रही हैं. Azbiya, are you here?
Assalamu alaikum. I'm Azbir Shakur. I'm a mechatronics engineer and I've been associated to EV industry for past 4 years. Today I am representing National Energy and Transport Corporation under the ambit of Ministry of Defense Production. So as NETC, we are proud owner of the biggest EV bus fleet across the country. We have executed a very big project with Sindh government, which includes 290 hybrid buses and 50 EV buses, and also we have like 37 EV buses in pipeline, including 7 double-decker buses. Also, we are working with Punjab and KPK government to execute 560 electric buses. So my question is, whenever we talk about retrofitting or conversion, why do it has to be every time some like two-wheelers or three-wheelers? Why are we not talking about electric buses? क्योंकि एक जो बस है वो ज्यादा पैसेंजर्स को कैरी कर रही होती है एक टाइम पे. सो पोटेंशली हम लोग जिस मेन चीज पे हम लोग बात कर रहे होते हैं वो होते हैं कि भाई पोटेंशली हमारे कार्बन फुटप्रिंट्स हैं वो रिड्यूस होंगे. सो व्हाई नॉट वी आर टॉकिंग अबाउट इलेक्ट्रिक बसेस. जितना हमने फिजिबिलिटी स्टडी की है, जो बड़ी बसेस हैं वो ऑलमोस्ट उनका फ्रेम प्योर मेटल पे है. So I just want to ask के उसके ऊपर भी कोई सक्सेसफुल स्टोरीज हैं. बट इफ यू टॉक अबाउट द स्मॉल बसेस, जैसे हमारे पास सिर्फ हम कैपिटल की बात करें तो हमारे पास नवल की बसेस चल रही हैं, कायद आजम यूनिवर्सिटी की बसेस चल रही हैं, डिफरेंट यूनिवर्सिटीज की इतनी ज़्यादा बसेस चल रही हैं. इफ यू टॉक अबाउट द स्मॉल बसेस जो 6 to 8 मीटर की बसेस होती हैं, दे कम विद द कार्बन फाइबर फ्रेम. So why aren't we going towards why aren't we going for it? Why are our industries just talking about conversion of small vehicles?
Well, जो बसेस हैं उसका पोटेंशियल ज्यादा है डेफिनेटली. द प्रॉब्लम इज दैट द कॉस्ट ऑफ द अडॉप्टेबिलिटी. किसी भी
Yeah.
बस के प्रोजेक्ट को आप अडॉप्ट करेंगे तो उसकी लेट अज्यूम आपने 100 to 100 किलोमीटर की वो करनी है, तो उसमें 400 किलोवाट आवर की बैटरी लग रही है, 300 किलोवाट आवर की वो लग रहा है. तो उसकी रेंजेस के ऊपर, क्योंकि कॉस्ट ऑफ अडॉप्टेबिलिटी ज्यादा है, तो अभी क्योंकि ईवी का कल्चर पाकिस्तान में नया है, ये कुछ प्रोजेक्ट्स होंगे जिसमें कॉन्फिडेंस बिल्डिंग होगी। अगर आप पाकिस्तान को देखें, सोलर की अडॉप्शन या सीएनजी की अडॉप्शन में शुरू में तो लॉजिकली तो वो ठीक था, लेकिन लोगों ने पाकिस्तानी वेट करते हैं, और इट इज ऑल ओवर कि कुछ लोगों ने लीडर होंगे वो वेट करेंगे, और विद सक्सेसफुल स्टोरीज और केसेस के बाद फिर एकदम लोग उस तरफ चलना शुरू हो जाएंगे। लेकिन
True.
अभी क्योंकि इस किस्म की रेक्टिफिकेशन, क्योंकि अभी ई बाइक्स वगैरह डेफिनेटली जो कमर्शियल प्रोजेक्ट्स हैं, ठीक है, उसमें ब्रेक इवन ज्यादा है। आप ट्रक ले लें, आप बसेस ले लें, आप कमर्शियल ट्रांसपोर्ट ले लें, पूरी दुनिया में क्योंकि आपकी डेली चार्ज और डिस्चार्ज जब होगी उसी में आपका रिटर्न है।
Yes.
Uh,
True,
Can I
but
add something?
okay,
thank
okay,
you, sir.
sure.
जी ऐसे
मैं
है
मैं
कि जो चाइना में कन्वर्जन हो रही है दैट इज नॉट फ्रॉम फ्यूल व्हीकल टू 100% इलेक्ट्रिक व्हीकल। जो कन्वर्जन हो रही है उसको टर्म दे रहे हैं पैरेलल हाइब्रिड। सो पैरेलल हाइब्रिड इज अ प्लग इन हाइब्रिड
Yeah.
व्हीकल्स। दैट इज द मोर कॉमन कन्वर्जन मेथड है। और इसमें जो एक पहले भी एक क्वेश्चन आया था कि उसकी डायनामिक्स को और वो सारी चीज़ें चेक की गई हैं या नहीं। तो इसमें सिर्फ आपको जो है वो इलेक्ट्रिक मोटर इंस्टॉल करनी पड़ती है लाइन लाइन विद द ड्राइव ट्रेन के दरमियान में। सो इट
Yeah.
इज़ अ वेरी इजी एंड इज़ अ कॉमन मेथड। सो हम एक चाइनीज ग्रुप है XDLE, तो वो एक्चुअली सेल मैन्युफैक्चर करते हैं और उनके साथ जो है वो मोस्टली मोर देन 100 बसेस जो है वो ट्रांसफॉर्म कर चुके हैं। सो प्लग इन हाइब्रिड जो है दिस इज वेरी कॉमन इन चाइना, और इसकी तरफ जो है ना जा सकते हैं। अगर 100% ईवी की तरफ जाएंगे तो कॉस्ट इतनी चली जाएगी, यू हैव टू बाय न्यू कार। आपका जो फ्यूल इंजन है वो भी आपके इस्तेमाल में रहेगा और आपको जो है उसकी माइलेज भी ज़्यादा मिलेगी। लाइक हमने जिस व्हीकल के ऊपर काम किया 54 किलोवाट की बैटरी के साथ, और उसके पर डे वो उसको होम में यूटिलाइज कर रहे थे। तो एवरेज उसकी जो इकोनॉमी है शेयर था हाउस के अंदर $150 पर मंथ जो है वो सेव कर रहे थे उसको डोमेस्टिक में यूज करने के लिए। और जब उन्होंने लॉन्ग ड्राइव किया तो उनकी वन चार्ज एंड वन फ्यूल टैंक के साथ 1000 किलोमीटर तक माइलेज मिला। सो द बेस्ट
Okay.
फॉर द पैरेलल हाइब्रिडाइजेशन।
As you
Okay.
know, as far as EV
I wanted
conversions are concerned, actually all across the globe, ये EV conversions पे काम हो रहा है। जैसे फेल्टन है, वो अपनी पुरानी बसेस एंड इवन ट्रक्स को
Even garbage
कन्वर्ट कर
trucks
रहे
they have
हैं
converted.
टू
Yeah.
इलेक्ट्रिक। मगर
Yeah.
पाकिस्तान में क्योंकि हमारी अभी कोई ऐसी पॉलिसी या रेगुलेशंस नहीं बनी फॉर EV कन्वर्जन्स, ना टू
Yeah.
व्हीलर्स के लिए, थ्री व्हीलर्स के लिए, ना ही बसेस के लिए। तो अभी ये वाला जो वेबिनार करवाने का मकसद यही था कि हम डिफरेंट इंडस्ट्री के डिफरेंट डोमेन से लोगों को बुलाएं और उनके कंसर्न्स और जो जो उनकी इनपुट्स हैं वो लें, और फिर इसी तरीके से हम एक उसका एक पूरा रेगुलेटरी फ्रेमवर्क डेवलप करें। नीका उसमें जो रोल प्ले कर सकता है वो करे। वैसे तो जो ऑल अक्रॉस द ग्लोब आप देखो तो होता ही है कि आप जो बसेस के लिए आप ग्रॉस व्हीकल वेट निकालते हैं, उसके उसके अकॉर्डिंग फिर आप मोटर को सिलेक्ट करते हैं। मगर अभी क्योंकि यहाँ पर EV कन्वर्जन की अडॉप्शन बहुत ज़्यादा स्लो है, तो दैट इज वाई अभी इसके ऊपर बसेस के ऊपर इस तरह काम नहीं हो रहा है। आई एम हैप्पी टू हियर
I
कि आप लोग NETC जिसका नेशनल एनर्जी एंड ट्रांसपोर्ट कॉरपोरेशन है, तो ये इनिशिएटिव ये वाला ले सकता है कि पुरानी बसेस जिस तरह से यूनिवर्सिटीज़ हैं या स्कूल्स की वैन्स वगैरह हैं उनको कन्वर्ट किया जाए टू इलेक्ट्रिक व्हीकल, टू रिड्यूस द रनिंग पर किलोमीटर रनिंग कॉस्ट और उसके ऑपरेशनल
Yes.
कॉस्ट को कम किया जाए। तो
So what we expect from NECA or other authorities that they need to define some, we need to, if we are investing that much on buses, then we need के हम लोग legally कहाँ पे stand करें, हमारे जो vehicles हैं वो legally कहाँ पे stand कर रहे हैं. So it can be a good initiative on national level.
बिल्कुल बिल्कुल इसी वजह से हमने आज जो PSQC को भी इसमें इसको इंक्लूड किया है। डिफरेंट इजी बाइक है, जिस तरह इंटरनेशनल एक्सपर्ट्स को हमने इसमें इंक्लूड किया वेबिनार में, सो दैट हम एक इंटरनेशनल हमारा एक्सपोजर हो कि वो किस तरह से काम कर रहे हैं। ये ना हो कि हम एक तरफ निकल गए हैं और दुनिया कहाँ जा रही है और हम एक EV कन्वर्जन्स में किसी और तरफ जा रहे हैं। थैंक यू सो मच
I just
एवरीवन।
wanted to make a point here कि like we already discussed कि यहाँ पे पाकिस्तान में we talk about पाकिस्तान, तो इंडिविजुअल जो कार ऑनर्स हैं हमारे पास वो इतने ज्यादा नहीं है, थाउजेंड्स में है, 15% और समथिंग. So if we go to like the ambulances running in the cities, the school buses, the school vans, the taxis, if we go, अगर हम उनकी तरफ जाते हैं, I think it is more successful for Pakistan to even reduce carbon emissions and things.
Exactly.
So यहाँ पे authorities हैं, so I just wanted to make this point कि जो भी इस पे वो करे.
Thank you so much, everyone. As we conclude, I would like to extend my sincere gratitude to all our distinguished speakers and participants for their valuable contributions. And this discussion has highlighted that EV retrofitting is not only a technological solution, but also a socio-economic opportunity for Pakistan, helping us reduce oil dependency, reduce carbon emissions. So, on behalf of NEECA, thank you all once again for being a part of this important dialogue. We look forward to continued collaboration as Pakistan takes concrete steps towards clean mobility. Thank you so much. Take care and Allah Hafiz.